Hi, this is Mrs. Holbrook again with Basic STEM, and we've done a little bit of algebra review, so we're going to move into geometry. That doesn't mean that the algebra isn't going to be used because we use a lot of algebra in this geometry book. The first lesson we're going to focus on is Lesson 7-1, dealing with proportions, so this should still feel a little bit like a review. Okay, main ideas in vocab. We're going to be able to write ratios and use properties of proportions. We're going to look at the word ratio, proportion, and cross products. If you remember cross multiply and divide, we're going to see that. The next two words we really aren't going to focus on, so don't even write those down. No extremes, no means. So here's our first example, write a ratio. The total number of students who participate in sports programs at Central High School is 520. The total number of students in the school is 1,850. Find the athlete to student ratio to the nearest tenth. So ask yourself, what are we comparing? We're comparing athletes to the total student body. So that's exactly what this tells us to do. So 520 to 1,850 works out to be about 0.3. So the ratio is 0.3 to 1, or you can just leave it as 0.3, which is your answer. So try this one on your own in your book. The country with the longest school year is China with 251 days. To find the ratio of school days to total days in a year for China to the nearest tenth, or find the ratio to the nearest tenth, use 365 as the number of days in a year. So we're comparing school days to total days in a year. And here are your answer choices. I will be looking for an answer to this question. Okay, and I'm sorry if that moved past that slide a little too quickly. Here's a test example, and they're going to work through this whole thing so you don't have to do this one on your own yet. In a triangle, the ratio of the measures of the three sides is 5 to 12 to 13, and the perimeter is 90 centimeters. Find the measure of the shortest side of the triangle. Well, remember, a ratio is comparing two things, and in this situation we're going to apply the ratio to these numbers. So you're asked to apply the ratio to the three sides of the triangle and the perimeter to find the shortest side. So we're going to solve this item. We can rewrite 5, 12, 13 as 5x to 12x to 13x and use those measures for the sides of the triangle. Okay, because this x is the common ratio between all three. We need to write an equation to represent the perimeter of the triangle as the sum, or all three sides, added together. So here's the example of our triangle. So we know that 5x plus 12x plus 13x equals 90 because it's the perimeter all the way around the outside, and they gave us the 90 in the story problem. So we combine like terms here. 5 plus 12 is 17 plus 13 gives us 30. Divide each side by 30 and you get that x equals 3. So we're going to use the value of x to find the measures of all three sides of the triangle. We know that 5x is the smallest side, so 5 times 3 is 15 centimeters. 12 times 3 is 36. 13 times 3 is 39. The shortest side is 15, so if you wanted to go back and look at your answer choices, the answer would have been A, 15 centimeters. Okay, and then if you want to double check, add these three numbers together and you will get 90. Okay, here's one for you to work out. In a triangle, the ratio of the measures of the three sides is 3, 4, 5, and the perimeter is 42 feet. Find the measure of the longest side of the triangle. Okay, so you may need to pause to write this problem down, and then we will move on. Again, I will be checking in your notebooks for this question. Okay, key concept, property of proportions. For any numbers A and C, and any non-zero numbers B and D. Now, why they say that is you can't have a fraction with a 0 in the denominator. It just doesn't work. It's kind of one of those math laws, and having a 0 down here breaks the law. So if and only if AD equals BC. So remember, this is the cross multiply. AD, BC. So here's an example. 4 fifths equals 12 fifteenths. If and only if 4 times 15 equals 5 times 12. Okay, so they're saying this only works if when you cross multiply, if the numbers match. Well, in this case, 4 times 15 is 60, and 5 times 12 is 60. So these would be proportions. So an example, solve proportions by using cross products. So cross multiply and divide. 6 over 18.2 equals 9 over y. That's the original problem. Cross multiply 6 times y is 6y. 18 times 2 times 9, or 18.2 times 9, gives us 163.8. Divide each side by 6, and we find out that y is 27.3. So that's your answer. Now here's a more complicated problem where they give you an equation in the numerator. So we're going to solve 4x minus 5 over 3 equals negative 26 over 6. So they show us first what's being multiplied. So 4x minus 5 times 6, 3 times negative 26. Now even though the 6 comes after this set of parentheses, we still need to use the distributive property. So 6 times 4x is 24x, 6 times negative 5 is negative 30, and then 3 times negative 26 is negative 78. So that's simplified. Add 30 to each side, we get 24x equals negative 48. Divide each side by 24, and you find that x is negative 2. Alright, here's one for you to try. Again, I will be looking for this in your notebook. So if you need to press pause to write down your problem, that's fine. Here's another problem for you to try, similar to the second example we just did. Again, I will be looking for this in your notebook. So if you need to pause the video to write this down, take a second to do that. Okay, an example, solving problems using proportions. Trains. A boxcar on a train has a length of 40 feet and a width of 9 feet. A scale model is made with a length of 16 inches. Find the width of the model. Because the scale model of the boxcar and the boxcar are in proportion, because the scale model of the boxcar and the actual, I would like actual in their boxcar, are in proportion, you can write a proportion to show the relationship between their measures. Since both ratios compare feet to inches, you don't need to convert all the lengths to the same unit of measure. So we have the boxcar length in feet to the model length in inches. The boxcar width in feet to the model's width in inches. So we knew that we had 40 feet was converted to 16 inches. We know 9 feet, but we need to figure out how wide it was. Cross multiply, 40 times x is 40x. We need to figure out what 16 times 9 is. So we multiply and get 144. Divide each side by 40, and we get roughly 3.6 as your answer. So the width of the model is going to be 3.6 inches. Here's another problem for you to put in your notebook as an example. Two large cylindrical containers are in proportion. The height of the larger container is 25 meters with a diameter of 8 meters. The height of the smaller container is 7 meters. Find the diameter of the smaller container. So we can do height to height and then diameter to diameter when you set up your cross products or your proportions. And let's see what you get. Again, you may need to pause this to write down information for the problem. Alright, that is the end of this lesson number 1 from chapter 7. You should have several examples written down and 4 problems, 5 because number 3 had an A and a B, written in your notebook for us to go over together at the start of class tomorrow. Good luck. If you have any questions, make sure you write those down too.